Hello everyone, myself Vijay, and today we are covering a topic known as the flux coupling. Uh, in the content of metabolic network, the flux coupling referred to as the functional dependency between the two reaction. We can say the metabolic reactions. It means the activity of one reaction can influence the activity of the another reaction. There are mainly three type of coupling: the directional coupling, the partial coupling, and the full coupling. In the directional coupling, the activity of the reaction implies the activity of the another reaction, but the necessary of vice versa is not, we can say. For example, if a reaction A react with B but also activate the B, but the reversal cannot be like activate in the same way, like reaction B may be or may not be affect the reaction B A, sorry. The partial coupling, the second is the partial coupling. The activity of one reaction implies the activity of the other and the vice versa. However, the two reaction have a different flux rate. In this, the both the reaction have different flux rates. In the third one, the full coupling, the activity of one reaction implies a fixed or we can say non-zero flux through the another reaction. The two reactions are tightly linked and their flux are directly proportional. Like that, one reaction directly affect the another reaction. The next question came here: why is the flux coupling important? Why it is so important? Under like understanding the metabolic network, the analyzing the flux coupling reaction can help us to understand the underlying mechanism of the metabolic pathway and how they regulated. Metabolic engineering, by identifying the key flux coupling reaction, we can like design the targeted genetic modification to the optimized metabolic pathway for the specific purpose, such as to produce a valuable chemicals or the biofuels. In this reaction, we uh, in recently we making the synthetic diamonds uh, with the help of this portion. In that, the heavy first of all, th- um, a carbon product is used in this for making these diamonds, and they have same life as the diamond have. They have the same shining as the diamond have, but they are made synthetically in the laboratories, but not in uh, the nature. We found diamonds mostly in the nature, but nowadays the synthetic diamonds are also being made in the laboratories. And the third one is the metabolic engineering. By defining the key flux coupling reaction, we can design a targeted uh, like biofuels or the chemicals, uh, optimized metabolic pathway to specific purpose for pursuing or making a specific biofuels or the chemicals. Nowadays, we know the ethanol fuel is mostly used. Uh, in few years, into five in last 5 years, we are using it. Before that, the petrol and the diesel are only the two options which we have. But in the ethanol fuels, we use the uh, sugar cane as we can say cofactor for increasing the productivity of or the efficiency of that fuel. It mostly in the some of the countries this step have been taken from many central and the state governments. This also help in the like drug discovery. Understanding the coupling can help the identifying the potential drug target that can distribute the metabolic pathway involved in a disease. like we can easily find out like which like which medicine is more suitable for a specific like antigen or any infection or any virus. Now, their method of analyzing the flux coupling. First of all, the FBA, known as the flux balanced analysis. Second is the EMA, as the elementary mode analyzing. The third one, FCA, flux coupling analyzing. Now we first of all see the first of the flux balance analysis. This method calculates the steady state flux distribution in the metabolic network under the specific reactions. Like we directly calculate how a product or how another reaction can get affected with the different reaction. We direct calculate it, like in the sense of like reactive time, half time of the reaction. These are mostly used in the chemistry's field, and nowadays it's also used in the biology and the pharmaceuticals for the like producing new and new drugs which can react easily and quickly. The second is the elementary mode of analyzing. This method identifies the minimal state of the reaction that can operate independently in the metabolic reaction. In the second, the elementary mode of analysis. In this, we look how much or the minimal amount of like any product or like a drug or a chemical or any fuel or any other reaction can we can get more and more product from the minimal substance. By putting minimal substance we get more and more product. In the third one, the flux coupling analyzing, this method specify the focus and the identifying and the characterizing the flux coupling reaction between the pair of reaction. In this we use like two different reactions to calculate the time. And after that, I have also another topic of the coupling of the chemical reaction, how these chemical reaction are doing their work, how they compatible with each other. In the chemistry, a coupling reaction is the type of reaction where the two reactant molecules are bonded together, often with the aid of the metal catalysis. Here we have the two reactant molecule and one is an metal catalysis. Uh, this process typically involves the formation of a new carbon-carbon bond. In this, new carbon-carbon bond are formed. The type of the coupling reaction we have are the homocoupling or the heterocoupling. In the homocoupling, this involves the coupling of the two identical molecules, like not same but identical. Identical in maybe in the form of the formula or may in the shape like pentagon, hexagon rings or the phenol rings, like that. We have the heterocoupling, the cross coupling. This involves the coupling of the two different molecules, like two different molecules. uh, as we know in the chemistry, we know about the Charles molecules which look like same but having the mirror image of each other, or maybe different like carbon or hydrogen molecules, or maybe different other molecules. Actually the carbon and hydrogen, they are the atom, but the complex which are formed from these by getting attached to each other, we can say they are different. Like now we have the example of the coupling reaction. We have the Suzuki coupling. This reaction involves the coupling of the aryl or the vinyl halides with an aryl or uh, halides, and the bronic acids are used, as the two substance, and the third catalyze, or we can say the metal catalyze here, is used as the palladium catalysis. uh, why this name as the Suzuki coupling? Because um, these are used in the like car cars, in the exhaust of the cars, for the minimum of the like exhaust producing so much smoke and different elements in the environment. So we want to cut down that ratio, or we want to do the minimum uh, like pollution in the environment. We used these. We have Nagasaki coupling similar to the Suzuki coupling, but use the organizing reactant instead of the bronic acid. Here the organozinc is used as uh, exchange of the bronic acid, and there are many more examples. Now we goes on the mechanism of the coupling reaction, how they work. What is the main mechanism after this? The mechanism of the coupling reaction generally involves the several steps, like oxidative addition, transmetallization, and the reductive elements. Why only these three are? Because we have only two substance and the one catalyzed catalase, which is the metal. So we have transmetallase here, and the two substance, they can like oxidize or reduce, so that we have this mechanism. In the oxidative addition, the metal catalyzes insert into the carbon halogen bond of the organic halides. In this, the like metal catalyzes insert in between, goes in between the molecules of that metal, goes in between the carbon halogen bond for forming the organic halides. In the transmetallase, the organic groups from the organometallic reactants are transferred to the metal catalysis. In this, the organic material like reagents goes into the catalyze. As we see in the normal reaction, the catalysis only fast the reaction or reduce the reaction, but in this transmetallizing are here in taking place here. The reductive elements, the two organic groups on a metal catalysis, combines to form a new carbon-carbon bond. Regeneration of the metal catalysis, as we seen in the synthetic carbons, like synthetic diamonds. Here the replacement of the carbon bonds. Thank you. That's all for the video, and hope you understood the topic very clearly. If uh, you have any questions or any doubts, you can comment below. I will give answer of them. Thank you very much. Have a nice day.